Hi everyone, today we're going to start the last section of Chapter 8, which is 8.6, Identify Special Quadrilaterals. Quadrilateral ABCD has at least one pair of opposite angles that are congruent. What type of quadrilaterals meet this condition? For this section, it's very important that you have all of your definitions of quadrilaterals and the different types, as well as the properties for all of our quadrilaterals. So think about all the quadrilaterals that we've learned so far and which ones have at least one pair of opposite angles. Well, one would be a parallelogram. If I were to sketch this out, we know that they actually have two pairs of congruent angles that are opposite, and this said at least one pair, so that one works. Looking at parallelograms, there are different types of parallelograms. We have a rhombus, and this would work for a rhombus, so let me sketch out my rhombus. So we know that those angles would be congruent. We also have a rectangle. And we know that those angles would be congruent. And finally, we have a square. And we know that those angles would be congruent. There is one more quadrilateral where the opposite has at least one pair of opposite angles that are congruent. Can you think of that one? And the answer is a kite. So if I sketch out a kite, I know that these opposite angles here are congruent. Match the property on the left with all the quadrilaterals that have that property. All right. This would be something I would definitely write in your notes, something easy to kind of see all the different properties when we have all of our special quadrilaterals here. All right, number one, both pairs of opposite sides are parallel. The quadrilaterals for this one would be a parallelogram, a rectangle, a rhombus, and a square. Number two, both pairs of opposite sides are congruent. Once again, that would be a parallelogram, a rectangle, rhombus, and a square. Number three, both pairs of opposite angles that are congruent, which would also be a parallelogram, a rectangle, a rhombus, and a square. Number four, exactly one pair of opposite sides that are parallel. And that would be our trapezoid, so a normal trapezoid as well as an isosceles trapezoid. Number five, exactly one pair of opposite sides that are congruent. Our keyword is only exactly one pair of opposite sides, so that would be an isosceles trapezoid. Exactly one pair of opposite angles that are congruent. That would be our kite. Diagonals are congruent. That would be our rectangle, our square, as well as an isosceles trapezoid. And finally, diagonals that are perpendicular. That would be the rhombus, the square, and an isosceles trapezoid. Now we are going to give the most specific name for the quadrilateral, and then we're going to explain. So for number 9, if we look at this quadrilateral, we see these tick marks. So these tick marks mean that these diagonals bisect each other, but they're also the same length. So since that's the only thing that we know from the previous slide when we had all of our properties, we know that a rectangle, a square, an isosceles trapezoid, we know that the diagonals are congruent. Since we only know that those diagonals are congruent, the only one we could say that this is would be a rectangle. We are unable to say that this is a square. All right, so number 10, What is the most specific name here? Well, if I look at this diagram, I see parallel lines. I also see that these base angles are congruent. So the most specific name here would be an isosceles trapezoid. And the last one, number 11 here, once again, I notice that my diagonals bisect and are congruent. I also notice that my diagonals are perpendicular. They create a 90-degree angle, meaning that this is a square. Tell whether enough information is given in the diagram to classify the quadrilateral by the indicated name. And we want to explain. So for the first one here, is this enough information to prove that this is a parallelogram? Yes or no? The answer is yes. Why? Because both pairs of opposite sides are congruent. 13, is this enough information to prove that this is a square? Yes or no? The answer is yes, because by definition, the definition of a square is that it has 4 congruent sides and 4 right angles. Number 14, is this enough information to prove that this is a trapezoid? Yes or no? The answer is no. It does tell us that we have base angles that are congruent. However, we do not know that this side and this side are parallel. That's something important to be able to prove that this is a trapezoid. So no, cannot determine parallel sides. What is the most specific name for the quadrilateral ABCD? Is it a parallelogram, a rhombus, a square, or a rectangle? The correct answer here is parallelogram. Why? If we look at what's given, we do see that our diagonals bisect each other, which is the definition of a parallelogram. However, that's all that we know. So we don't know anything about the sides or the angles here. So since that's the only information given, we can only prove that it's a parallelogram. And that's all for today's lesson.